So let's start off talking about what a permutation is. So if I'm given a set of elements, and those elements could be characters in a string or numbers in an array, if I'm given a set, then a permutation is a unique combination or arrangement of those elements. So if I'm asked to find all the permutations of a string or all the permutations of an array, it basically means that I need to find all of the unique combinations that you can make with those elements. So for example, if you're given the letter A, then you can make one permutation. The only string that you can make with this letter is A. If you're given the characters A and B, right, now you have two elements, then you can make two combinations from this string, right? You can make A and B and then B and A. So if you're given A, B, and C, it turns out that you can make 6 permutations or 6 combinations. And this is mathematically represented by a factorial. So in factorial, where n is the number of elements in your set. So in this first example here, we had one character. So 1 factorial is equal to 1. In the second example here, we have 2 letters, so 2 elements in our set. So that would be 2 factorial, which is 2 times 1, which is 2 combinations. So we can make 2 combinations, 2 permutations from these 2 elements. In the third example, we have 3 elements, right? So we can make 3 factorial because we have 3 elements in our array, so it's 3 factorial, which is 3 times 2 times 1, which is 6. So we can make 6 combinations with the string A, B, and C. So let's see how we can do that. Let's take A, B, and C, and let's make those combinations. So starting off with the first character, with A, how many combinations can we make starting off with that? So A, we can make A, B, and C. We can make A, C, and B, and that's about it, right? So let's move on to the next character. So starting off with character B, we can make B, A, and C, and we can also make B, C, and A, okay? And then starting off with the C character, with character C, we can make C, A, and B, and we can make C, B, and A. So those are our 6 permutations right there. So let's make some observations and try to figure out how we can do this programmatically, right? Every character in our string happens at least one time. So this A right here, there's going to be a permutation, at least one permutation starting off with A. There's going to be at least one permutation starting off with B, and there's going to be one permutation starting off with C. So from that observation, what we can do is we can basically say, well, let's loop through our characters, right, our elements in our set, and let's try to build up a combination or a permutation from that. So let's start off with an array of all the possible combinations, right? So this array right here represents all of the possible combinations that I can have to build up one permutation or a permutation. So we're going to call this subarray. We're going to just call this a subarray. And so then in a different array, we're going to say this is the array that we're trying to build up. This is the permutation that we're trying to make. So again, each of these letters is going to appear in the permutations as the beginning letter at least once. So what we're going to do is we're going to loop through each of these elements, right? So let's say that this is element 0, this is element 1, and this is element 2. So when we start our loop, we can say, okay, so we're going to start off at A. When I start off at A, I'm going to take that character or that element, and I'm going to move it to over here on the right-hand side to A here. That means that I have now I've started creating a permutation, right? I'm not done with it yet, but I've started creating a permutation. When I move this element when I copy this element over to this permutation array, then I need to remove it from here because I'm not going to have A as any other choices to create my permutation. You'll notice up here that none of the letters were repeated. So we're not going to repeat any of these elements anytime in our permutation. All letters are going to be unique, right? All letters are going to be used once. So once we take an element from our valid remaining character set and we put it into the permutation that we're trying to build, we're going to remove it from this permutation set. So we're going to remove this element from here. Okay? So the remaining valid characters that we have left to build up a permutation would be B and C, right? So what we're going to do is we're going to use recursion to solve this. And what we're going to do is we're going to build a function that takes in two arguments. The first one is going to be a subarray. And that subarray is going to be represented by all this right here, the remaining valid characters that I have left in order to make up my permutation that I'm trying to build. And then the second array is going to be the permutation that you're currently trying to build, right? So this is going to be the permutation that you're currently trying to build. And that is represented by this over here. Okay, so what we're going to do is we're going to take this function and we're going to recurse. So now we're going to call this function and we're going to pass in the subarray, which is this over here. So we're going to pass in that subarray B, C. And then we're going to pass in also this permutation array. And this represents the permutation that we're currently trying to build. So here, we're going to pass in A. All right? So now we have recursed. And now we're going to look at this and say, okay, well, we need to iterate over this subarray, right? So we need to iterate over these elements right here. And when we iterate over them, we're going to remove the element that we're currently iterating over, and we're going to place it inside of this permutations array over here. So on the right-hand side, let's start off with, we have an I currently of equal to 0, right? So we're on B. So if we have this array right here, and this is the array that we're trying to build, then what we're going to do is we're going to remove the B, right? So we're going to remove B from our array, and we're going to place it inside of the permutation array, right? So now we have an array. So this was when I is equal to 0. So when I is equal to 0 up here, we have B, right? So we're going to remove B and put it into the permutations array that we're trying to build up. And then we're going to recurse again. So this is going to be the recursion. So this was the recursion for here. And then we're going to recurse again. So we're going to say, take our function, and we're going to pass in the subarray, which is this right here. So we're going to pass in that subarray, which now is just C. Those are that's the valid remaining characters we have left over to build up our permutation array. And then we're going to pass in the current permutation array that we are currently working on, right? So now we're going to take our C, and there's only one element. We're still iterating over it, but there's only one element. And we have A and B. So we're going to iterate over this, but we only have one element. So we're going to remove this C from here. This is the last valid character that we have from our subarray. And we're going to place that over here in our permutations array that we're trying to build up. And so at this point, we have a valid permutation. We've found a valid permutation. How do we know that we've found a valid permutation? Well, it's because this array right here is empty, and we have no other remaining valid characters left in order to build this array. So when our subarray reaches a length of 0, then we know that we have found a valid permutation. And if we look up here, one of the valid permutations is A, B, and C. So after this is complete, we would take this right here, this valid permutation, and we would push it to some main array called like found permutations. So this is going to be an array of arrays. So we've found our first permutation, A, B, and C, right? All right, so then we would go back up, right? Because we have still calls sitting on the call stack. We would basically go back up to right here. We haven't completed this function yet. We have iterated through the first element of this array, like over here, but we haven't iterated through the second element of the array. So we need to complete that so that it can be popped off the call stack. So over here, we're gonna have I is equal to 1 now, right? And we have still the array B and C, but when I is equal to 1, so this was when we were building up an array, a permutation with just one element with A. So we have this array and I is equal to C now. So again, we're going to take the value at I and we're going to remove it from our subarray. And then we're going to take that element, the value of that element, and we're going to place it into the array that represents the permutation that we're trying to build up. So now we have a subarray of one element with B in it and a permutation with A and C in it, right? So we're going to recurse again, and because we haven't found a valid permutation yet, and the reason why we know that is because our subarray still has one element in it. So we're going to recurse, and this time our subarray has element B, and our recursion, like our permutation array, has A and C. So at this point, we're going to take the element in B and our permutation array, A and C, and we're going to say, we're going to iterate over it, but we only have one element, right? So we're going to iterate over this. And when we iterate over this, we're going to say, okay, let's look at B, and we're going to remove this element from this array, and we're going to place it inside our permutation array. So that was B, right? So now we have reached a final, like our base case. We have found another valid permutation. And we know this because our subarray here has no more valid remaining characters left. So we've reached our base case, which means that we're going to take this permutation right here, and you can check to see that this is a valid permutation up here. We're going to take this permutation right here, and we're going to store it in our found permutations. So up here, we would take this and we would add one more permutation to it. And eventually, we're going to have 6 permutations inside of here, A, C, and B. So then we would go back. We have finished this part of our tree, right? So we would go back up to the top. And now we would do all the permutations. So that was all the permutations starting off with A. And now we would do the same thing, go down to the same exercise using B. So in the second case, when we're iterating through here now, then this would be represented by all the permutations starting off with B. So in the end, we would get BAC and BCA. And then once we got done with all of the recursion trees for B, then we go back up to the top and we would start off with C. So this would represent all other permutations starting off with C. So we have 2 of them, CAB and CBA. So we would go down through the recursion tree and we build up 2 more valid permutations and then add them to our found permutations. The problem here is to write a function that takes in an array of unique integers and returns an array of all permutations of those integers in no particular order. So if the input array is empty, the function should return an empty array. Otherwise, it returns all the permutations. So for example, if we have the array input 1, 2, and 3, then you'll get 6 permutations because you have 3 elements. So it's 3 factorial. So let's start off with a function definition called get permutations. And then we're going to call that function with the sample input 1, 2, and 3. So in the end, we should get an array of arrays where the inner arrays So it's a multidimensional array. And the inner arrays are all the permutations, the 6 permutations of the array 1, 2, and 3. Okay, so inside of this function, we're going to define a helper function called perms. And this function is going to take as an argument or as a parameter the subarray and the current perm. And this was defined in the conceptual overview. So at some point we're going to have to call this array, so we'll go ahead and call it, and we're going to call it with initially with the array that was passed into the parent array. So we'll pass in array, and then we'll pass in an empty array. So this is our subarray, and this is the current permutation that we're trying to construct. So this is the function that we're going to recurse with. So in the parent function scope, we're going to define an array called found permutations, which is going to be the array that we store all of our permutations that we find. Okay, so as with all recursive functions, we're going to have some type of base case, and we'll define that as we approach it, like as we get to our base case. So what we're going to do is we're going to start off with a loop. So we're going to loop through, so let's let I equal 0 and then I less than the subarray. So the subarray currently, right, I'm just going to put this right here. Currently the subarray, let's put it right here. Currently the subarray has the value of 1, 2, and 3. That's what we passed into the function when we called it. So this function is passing the array 1, 2, and 3 to the parent function, and then we're calling the inner function perms, and we're taking that value and passing it into this function right here. So the value of subarray is 1, 2, 3, and the value of current perm is an empty array. So this is going to go from 0 to the length of the subarray, which is 3, and then we're just going to increment it one at a time. All right, so when I equals 0, so we're going to be at I equals 0 at this point, we're going to define 2 variables. One is going to be called new subarray, right? So it's the subarray that we're going to define based on this old subarray. And for right now, let's just define it as null. And then we're going to have one other variable that we're going to define, and that is going to be a new current perm. And we'll just define that as null for right now. Okay, so let's construct this variable for a new subarray. It's going to be based on the old subarray. So essentially what we're going to do is we're going to try to slice out part of this array so that we can recurse again. So when I is 0, we want to take this first element here, and we want to take, so what we want to construct here is we want to construct a subarray with the elements 2 and 3, and then we want to construct a perms array, like the permutation that we're currently constructing, of 1. Okay? So when I is 0, we're going to, how we're going to do this is we're going to take the old subarray, so subarray, and we're going to slice off of it. So we're going to slice from 0 to I. So what that is going to give us when I is 0 is actually nothing, right? So what we're basically saying here is we have an array 1, 2, 3, and we're going to slice from 0 to 0, right? Because I is equal to 0 at that point. So that is not going to yield anything. But then we're going to chain on a function to this. So we're going to chain on concat, and concat works kind of like a, so we're going to concatenate on, which is kind of like a push, another sliced part of this subarray. So we're going to take subarray, and we're going to slice the elements from I plus 1. So this means we're going to concat the array 1, 2, 3, and we're going to slice the element at 1 because I at this point is 0. So we're going to slice from 1. So what that means when you slice something from 1 is starting at element 1, so 0, 1. So starting at element 2 to the end of the array, that is going to be your result. So we're concatenating, or we're pushing onto that the result of the slice from 0 to 0, which yielded nothing. So this is going to yield an array of 2 and 3, right? So that gives us that 2 and 3 right here. So now we just have to construct that new perms, which is 1. So to construct this, what we're going to say is we're going to take our current perms, right, which is an empty array, and we're going to concat, so it's kind of like a push, a non-mutating push. We're going to concatenate on the subarray, which is this array right here, 1, 2, and 3, and we're going to concatenate on I. So I is currently 0. So the element at I equals 0 is 1. So what we get here is an array. We're concatenating on to this current perm, which is empty. We're concatenating on 1. All right. So after that, we're going to recurse. We're going to call perms, which is our recursive function right here. And we're going to pass in 2 arguments. We're going, because that's what the function is expecting, a subarray and a current perm. So the subarray that we're going to pass to it is this new subarray that we've just constructed. So new subarray. And then the current perm that we're going to pass to it is going to be the new current perm. So what we have here is that perms is now has a value of, the first argument is an array with 2 and 3, and the second argument is an array with 1. So this is our remaining valid elements that we can construct our permutation with, and this is the beginning of our construction of our permutation. So we're going to recurse here with these arguments. So when we recurse, so let's go back, before we recurse and go into the details of that, let's go and let's make sure that we know what's on the call stack. So currently we have called get permutations. So get permutations with 1, 2, and 3 is on the call stack. And then we call this perms array here, which is also on the call stack. And we haven't completed it. So it's still on the call stack with, we're currently at I equals 0, right? And then so this is sitting on the call stack, and we make another call to perms. And this time we're making a call with these 2 arguments right here, right? So this array right here was actually the value of 1, 2, and 3. So we haven't completed this. It's still on the call stack. We haven't completed this, right? We're getting ready to go into the details of that. So we are now calling perms with these arguments. So let's go back up here. And so now our subarray is 2 and 3, and our current perms is 1. So I is actually still 0 because this is a brand new function call, right? So I at this point is 0. So we can put I equals 0 here. So we go down to here, and we have to slice off between 0 and I, so it's still 0, 0, and then concatenate. The array that we have now is 2 and 3. So we're going to concatenate, and so this array right here is 2 and 3. And so we're going to slice off starting at element 1, right, down to the end of the array. So that would mean that would yield us an array of 3. So now our new subarray is just an element of 3. And now we have to construct our new current perms. So our new current perms is a subarray at I. Well, the subarray at I, if this is our subarray at I equals 0, is the value of 2. So we're going to push to this array 2. So now we're going to call our recursive function again. And this time we're going to pass to it our new subarray, which has a value of 3. And we have a new perms array that we're constructing the permutation that we're trying to construct with a value of 2. So if we look at this in a picture, we started off with this array right here, and then we called this function right here with this subarray and this permutation. And then now we are getting ready to call the function again with a subarray of 3 and a permutation of 1, 2. All right, so this is still on our call stack. So now we have another function on our call stack, right? These functions right here have not completed. They're still on our call stack waiting to complete. So now we have a argument with, the first argument is an array with one element of 3, and the second one is an array with elements 1 and 2. So we call this, and now our values change, right? Our subarray is 3, and our current perms is 1, 2. All right, so when we get here, we're going to, our I is still 0. It's a brand new call on our call stack. So I is still 0. We have one element in our subarray. So from 0 to 0, that's not going to yield anything. And then from 1 to the n, so we don't have an element 1, so this actually is an empty array. And then we're going to take the new current perm and we're going to concatenate onto it, or we're going to take the current perm and concatenate onto the subarray at I. Well, the subarray at I is the value 3 because our subarray has one element, which is 3. So the subarray at I, which is 0, is going to yield 3. So now we have an empty array and we have this right here. So we're going to make another recursive call, and this time our recursion is going to be here. So now we have reached, if we remember from the conceptual overview, we have reached a valid permutation, right? Because we know this because our subarray is now empty. So what we said is when our subarray is empty, it's kind of like a base case. It is a base case. And what it means is that we're going to now push to this found permutation. So at this point right here, we're going to say if our subarray, so that we're constructing our base case, if our subarray dot length, the value is 0, then what we're going to do is we're going to take this found permutations and we're going to push the current perm. So what is the current perm? The current perm at this point is 1, 2, and 3, and then the subarray is empty. So we're pushing to this 1, 2, and 3. So we have our first permutation. So at that point, our first permutation is this gets executed, and we're finished with this function call, right? Because we can't loop through anything because there's nothing inside of our subarray. So this finishes, and then this means that this is taken off of our call stack. So if we look over here on our picture, we have found a permutation, and so now our found permutations, we've stored the 1, 2, 3 in our found permutations. So now this has completed, and this has completed because it's only one element in here, so we can't really loop through any more elements, right? There's only one element. So really and truly, we have to go back up to here. Now this one had 2 elements, and we left off at I equals 0, so it's still waiting on the call stack. So these 2 things down here get popped off the call stack. So we go back up here to f of 2, this array with elements 2 and 3, and the current perms of 1, right? So we're going to take, so we've taken this off the call stack, right? So that's this one down here, and we're going to take this off the call stack, right? So that's this one right here. And so now we're back up to here, right? And so if you didn't see that, this one had I equals 0, so we've already iterated through this element right here. We don't have anything else to iterate through. And then this one didn't have anything to iterate through. That's why we can pop, we're done with this function call. But this one right here, if you take a look, had 2 elements in the subarray. And this loop is looping through the subarray, the length of the subarray. So we still have another element to loop through here. So now I is going to be equal to 1, right? So at this point, what we're iterating through is the perms of 2 and 3, and then an I of 1, or a current perm of 1, and a subarray of 2 and 3. So our subarray is 2 and 3, and our current perm is 1. And our I at this point, because now we're on a second iteration, our I at this point is going to be 1. So now we have a slice from 0 to 1, right, of the array 2 and 3, and we're going to concatenate on the slice of 1. So from 0 to 1 means from 0 to 1, so up to 1 but not including 1, so that would give us element 2 in here. And then the slice from 1 to the n, 0, 1 to the n, is going to give us, we're just going to have the slice of I plus 1 is actually 2, right? So I at this point is 1, plus 1 is 2. So from 2 to the n, we don't have an element in here, a second, like an element with an index 2 inside of here. So this is going to yield nothing right here at the bottom, at the back end of this. So this right here now is our new subarray, is just 2. So our new subarray is 2. Our current perm, we're going to concatenate on. So our current perm currently is 1 right here. So we're going to concatenate onto it the subarray at I. Well, we're at an I of 1. So the subarray at I has a value of 3. So we're going to put 3 here. So now we have 1 and 3. And we're going to make a new, we're going to recurse again. So now we're recursing with this. So if we look at our picture here, we are recursing with the first subarray with 2, and then the current perm of 1 and 3. So now our I at this point is 1, right? Or our I at this point is actually 0. So we go back up here. Our subarray is going to be 2, and our current perm is 1 and 3. So here, if our I is 0, right? Because we just made a brand new function call. So we just recursed, right? So we're at I equals 0. So this is from 0 to 0 of 2 is just going to yield nothing, right? And then from 2, from I, which is 0, plus 1, which is 1. So the slice at 1. So at element 1, we're going to get nothing also. So this means that we're going to get an empty array. So we're going to get an empty array, and then we're going to push to the current perms the subarray at I. So the subarray at I, we're at 0. The subarray is this right here. So the subarray at index 0 is 2. So we're going to add to this the value of 2. So now we're going to recurse again. And this time we've reached a base case. This is empty now, so we know that we have a valid permutation, which is 1, 3, and 2. So now we're going to add, we've reached this base case right here. We're going to add to that found permutation a new permutation 1, 3, and 2. So we are done with this. We don't have anything else to iterate through. We're done with this because there was only one element to iterate through, and we've already done that. So we can pop that off the stack. And then we also can pop this off the stack because now we're at I equals 1. We've just finished that. So we don't have any other elements to iterate through. So if we look at our picture here, we've gone all the way down. We've pushed a new current perm to our found permutations. So we have completed all of these things right here have completed, and they've been popped off the call stack. So we're back up at the very top, where we're now going to iterate through I equals 1, or the value of 2. So we go back up to the top, and we have to construct a new permutation. So now we're at, again, 1, 2, and 3, right? So we're at 1, 2, and 3, but now we're at an I of 1. So we are back at 1, 2, and 3. and an empty array. So we have 1, 2, and 3, and an empty array. So at this point right here, we have an I of 1. And so we're going to construct this 1, 2, and 3, and 1, 2, and 3. So to construct this, we're going to say starting at I, so we're going to go from 0 to I, which it's from 0 to 1, or let's see, 0 to I, which is 1, but not including I, so that's going to give us an array or an element of 1. And we're going to concatenate onto that 1, 2, and 3 with a slice starting at I plus 1, which I is 1, plus 1 is 2. So 0, 1, 2. So this element to the very end. So this is going to give us a 3. So our new subarray is now 1 and 3. Right? So we have 1 and 3. So now we just have to construct our current perm. Our current perm is currently empty. So what this says is that we're going to concatenate onto this empty array the subarray at I. The subarray at I is, this is our subarray, and our I value is 1. So the subarray at I is a value of 2. So now we're going to make a new recursive call. And now we're at an I. This is a brand new recursion of I is equal to 0. It's like a brand new function call, right? So we're at I equals 0. We have the subarray of 1 and 3, and we have a current permutation of the element 2. So if we look at our picture over here, we get this 1 and 3, and then we get this 2. All right, so now we're going to construct this right here. So our new subarray is going to be from 0 to 0, which is going to yield nothing, and then I plus 1, which is just 1, so the slice of 1. So this means that starting at 1, 0, 1 to the very end, that's what we're going to get. We're going to get 3, right? So now we need to concatenate on to the current perm. We need to concatenate on the subarray at I. Well, this is our subarray here, and we're at I of 0, so our subarray at I is the value of 1. So our new subarray is the value of 3, and our new current perm has a value of 2 and 1. And so that will be our new recursive call. So we're going to put this on our call stack. And again, this is a brand new function call, so our I is at 0. So our subarray here is 3. Our current perm is now 2 and 1. So if we look at our picture over here, our current perm is 2 and 1, and our subarray is 3. So now we're at I equals 0. So we just have this element right here. So this first part is not going to yield anything, and the second part is going to yield an empty array. Then we're going to take the subarray at I. So the subarray at I, which I is 0, is going to give us 3. So this is going to be 3. So now we have 2, 1, and 3 as our new current perm, and our subarray is empty. So we're going to make this recursive call. And when we make this recursive call, this is empty right here. We reach our base case. So that means that we have found a brand new valid permutation, which is 2, 1, 3. So we push that to our found permutations array up here. So now we have 3 valid permutations. So this gets popped off the call stack because we have nothing else to iterate through. This only had 1 element, so it also gets popped off the call stack. And so now we're left here because I equals 0, that's where we left off, but we have 1 more element to loop through. So if we look at our picture here, we have found a valid permutation. So now we have to go back up to here. We're going to pop this off the call stack, and we're going to go back up to here because we still have to finish iterating through this element right here. So now we're at an I of 1, right? And now currently our permutation where we left off here was 1 and 3 and 2. So that means our subarray is 1 and 3 and our current perm is 2. So this would be 1 and 3 and 1 and 3. So our I is 1. So this means that from the slice from 0 to 1 is going to be from 0 up to 1, but not including 1. So that means that we're going to get a value of 1 here. And then this is I plus 1, which is 1 plus 1, which is 2. We don't have the second element, so this remains at just 1 element here. So our new subarray is just an array with 1 in it. And then our new current perms, we're going to add to this value of 2, the subarray at I. The subarray at I, which I is 1, is the value of 3. So we're going to add to this the value of 3. Right? So now we're going to make another function call. And this time our I is equal to 0 because it's a brand new function call. So now we're going to go back up and our subarray is 1 and our current perm is 2 and 3. So this right here, down here, when we have everything inside of here, it's basically going to clear out our subarray, our new subarray. So our new subarray is empty, and we're going to add to it the subarray at I. Well, the subarray at I, the I is 0. The subarray at I is the value of 1. So now we have 2, 3, and 1, right? So we're going to make another recursive call. This doesn't have any elements in it, so we've reached a base case. So now we're going to take this array right here, and we're going to push it to the end of found permutation. So we found a brand new permutation. We pop this off the call stack. We pop this off the call stack, right? So if we go back to our picture, we have found a permutation, and we're going to go, and this was the value at I equals 1. So we've iterated through each of the elements here. So we pop this off the call stack, and we go back up to this right here at the very top. And now we're for the very top function right here, we're at I of 2, right? So down here for the perms, we're now at an I of 2. And we're back to 1, 2, 3, and this one being empty, and our I now is a value of 2. So we can put 1, 2, and 3 here, and then this is empty, right? So now we have to make this right side of the tree, and then we'll be done. All right, so you should see the repetition happening here, but I think it's good to walk through all of it and see it kind of how it all plays together. So let's see, we are at a perms of 1, 2, and 3, and we have this empty array. So that's what we have here. So now we're going to we're going to put 1, 2, and 3 here. And we'll go ahead and put 1, 2, and 3 here. So this is going to be from 0 to 2, right? And then this slice right here is going to be, I currently is 2, so 2 plus 1 is 3. So from 0 to 2 means 0, 1, 2, but not including 2. So it's going to give us these two elements right here. So that would give us 1 and 2. And then this part right here, we don't have an element at 3, so that doesn't yield anything. So now we need to figure out what we add to this empty array. So it says that to this current perm, which is this right here, this empty array, we're going to add to it the subarray at I. Well, this is our subarray, and our value of I is 2, so that's going to be the element with the value 3. So now our new subarray is this right here, 1 and 2. And our current perm is 3. So we're going to make a recursive call. We're going to place that on the call stack. And currently, when we call this, our I is equal to 0. It's a brand new function call. So now we go back. Our subarray now is 1 and 2. Our current perm is 3, and our I is equal to 0. So when I is equal to 0, so we can take this part off right here. When I is 0, then we're going to have from 0 to 0, which is going to yield nothing, and then we're going to have 1 plus 0, which is 1. And so this is going to yield for us, this is nothing, and this is going to be from 1, starting at element 1 to the n, so 0, 1 to the n, which is going to give us an element of 2. So then our current perm is 3, so we're going to push to this the subarray at I. The subarray at I, we're at I equals 0. The subarray at 0 for this subarray right here, for 1, 2, is a value of 1. Right? So now our current perm, our subarray is 2, and our current perm is the value of 3 and 1. Right? So where we are now is this 1 and 2 and this 3 right here. Or, I'm sorry, we're at the value, the subarray at 2, and then this value 3 and 1 right here. All right, so we're going to make a recursive call. And at this point, our I is at 0 because it's a brand new function call. So here we have our subarray has a value of 2, and our current perm is 3 and 1, and our value of I is equal to 0. So we'll remove this 1 here, and we'll remove this 1 here. And so this is going to be from 0 to 0, which is not going to yield anything. And then this is going to be this is going to be 1. So that means that this is going to clear out, and we're not going to have anything. It's going to be an empty string. So then to our current perm, it tells us that we need to push the subarray at I. Well, I is 0, and this is our subarray. So the subarray at I is going to yield 2. So our new subarray is now empty, and our new current perm has 3, 1, and 2. So that's the value that you see right here. So we have reached, we're going to make our recursive call, and at this point we make our recursion. We're going to hit our base case because the subarray length is equal to 0. So that means that we have found another valid permutation that we can push to the found permutations. So at that point, this gets popped off the call stack. We've already iterated through all of the elements of this subarray, so this gets popped off the call stack. And then we have iterated through the 1, but not the 2. So we have to keep on with the iteration. So now we have an I is equal to 1. So if we go back to our picture here, we're now at an I of 1, right? So we have to go and we have to construct that. So when we left off here, we were at 1 and 2 and a current perm of 3, right? So we'll go ahead and put that here. So we have a subarray of 1 and 2 and a current perm of 3. And at this point, our I is 1. So let's construct this real quick. 1 and 2 and 1 and 2. And then so we have from 0 to 1, which is going to give us 0 to 1. So up to 1, but not including 1. So this is going to give us a value of 1. And then this is going to give us 1 plus 1 is 2. We don't have an index of 2 here. So this is just going to yield an array with the value of 1 in there. So now we have to take our new current perm, which is 3, and we have to add to it the subarray at I. Well, this is our subarray, and our value of I is 1. So the index at 1 has a value of 2. So now our current perm has the elements 3 and 2, or the values 3 and 2 inside of it. So now we make another recursive call. And again, the I here is 0 because we have a brand new function call. So if our I is 0, we have a subarray of 1, and we have a current perm of 3 and 2. All right, so here we take this off and we take this off. Then from 0 to 0 is not going to yield anything, and then from 0 to 1, or this right here is going to be 1 plus 0. So this is going to clear out our array. So our new subarray is empty. And then the subarray at I, which I is 0, a subarray is 1. So we have 3, 2, and 1. So now we have one more recursive call to make, which is here. So now we've reached a base case, right? Which means that we've found the last permutation that we're going to push to the end of found permutations. So now we can pop this off the call stack, and we've completed this iteration, right? There was only one element to iterate through, so we can pop this off the call stack. We've completed both the iterations here because we're at I equals 1, so we can pop this off the call stack. And we've completed all of these iterations, 1, 2, and 3, right? So we have completed this 1, 2, and 3. So now we can pop this off the call stack. And this is going to, we're going to just return our found permutation. So that means that that last thing that we popped off the call stack was the perms right here, right? This is the perms right here. So now all we have to do is, the perms right here. So now we just have to return the found permutations, which is the array that we were constructing up here with all of the found permutations. So at that point, then this gets our recursion is done, so that gets taken off the call stack. And then this gets taken off the call stack because now we have the result. We have the result of all of our found permutations.